Hello, everyone. I welcome you all to the randomization topic of System Verilog, which is our module for part one. So we'll be discussing here about randomization and why do we constrain randomization and what are its benefits. So the points which we'll be discussing today are what is the benefit of randomization. So it helps us to design efficiently. We can do complex designing efficiently and with capturing bugs efficiently. Then we can have minimal code, which is needed for complex scenarios. System Verilog enables random transactions using this randomization process. And constraints also, if you constrain your randomization, it also leads to meaningful stimuli. So let's understand all these points with examples. So whenever you want to declare any variable in System Verilog as a random variable, there are two ways in which you can do. One is using rand, which is used for uniform distribution. We also have one more declaration which you can do using rand C for your variables. So rand C, C stands for cyclic here. So it's random cyclic, which is nothing but it doesn't repeat the sequence until that full cycle completes. So, for example, you can declare a variable packet length as a 16-bit variable. And since I want it to be randomized, I just prefix it with rand. It is of type bit, of length 16-bit. And the name is packet length, right? So when you do this, the different combinations one can have on packet length, I mean, it randomly generates different values for packet length, which is a 16-bit. So it is maybe it is 000 to 0. So this is my 0th position, and this is my 15th bit position, totally 16. And something later randomly, it may generate something like this, 111 up to 1 here. So randomly, it keeps generating a 16-bit value for your packet length variable. And randc is again something which cyclically generates your value to, here it is IPG. So IPG is a variable, which is a 2-bit variable, and it's randc. So that means in one cycle, it gives unique combinations to IPG. For example, it's 2 bits, so it is 0001 1011. So this finishes one cycle. And in the next cycle, again, it may start with the sequence, which is again the sequence of 0, 1, 2, 3, respectively. Okay. So in one cycle, within a cycle, there is no repetition of the random value. No repetition happens. All unique combinations will be generated. Well, that's not true in when you declare it as rand. So you may get repeated pattern, repeated value for your variable. So there is no guarantee that all unique values will be generated. Okay, so that's the difference between rand and randc. So how do you invoke these variables to generate random variables? So there is an inbuilt function, a built-in function in System Verilog, which is called as randomize. And this function cannot be overridden. Okay, so it's virtual and it cannot be overridden. So it randomizes all the variables which are declared as either rand or randc. Okay, so example, how do you instantiate the variables which are rand and randc? How do you instantiate them to generate values? You have to call the function randomize to the with invoking the class name inside which these variables are declared. Okay, so we can use rand and randc whenever the variables are in the class, inside the class. So they are class variables. Okay, then only you can use rand and randc and use the randomize function. So that's the combination you have to remember. For example, I'm here taking a class, name of the class is packet, and I've declared two variables here, which is packet length and IPG. So these two are the variables, and one is 16-bit and one is a 2-bit, right? While the declaration for packet length is uniform random because I've declared it as rand, and for IPG, it's random cyclic because I have declared it as randc, okay? And there is a function in the class which is a display function, which displays the values of packet length whenever it's randomized, calling the randomize function. Okay, so this is my entire class which I have defined here. So class packet, two variables and one function. Okay, then inside the module, call an instance of class, an object is created, which is PKT. So PKT is an object of type packet. That's the class. Then a local variable int I. Then I instantiate the packet. So it's like a constructor, built-in constructor. When you invoke packet equal to new, it declares the default values for all the variables inside the class packet. Okay, so then for some loop, repeated loop. For example, I'm running here this loop for 6 times, for 6 times here, and I'm instantiating class object dot randomize. When I say object dot randomize, object is PKT here. So whatever variables of this object are either rand or randc, they get randomized. Okay, and here it happens for 0, 1, 2, 3, 4, 5 times, right? Because 4 is up to I less than 6. So till 5. So that means 6 loops happen and 6 different numbers get generated, okay, for a packet length and IPG. And you parallelly display the values being randomized, calling the class function display. So with object dot display, you do that, okay? So if sometimes randomization may fail, may not be able to randomize the variables, then you have to check that also in the else part. So I'm checking that in the else part, saying that if the randomization do not happen. So if of packet dot randomize returns an error, then it goes to the else part and then it displays randomization failed. So that's about the program. So rand packet length generates a random value anywhere between 0 to 65535 because it's a 16-bit data. And randc IPG will declare initialize a data anywhere between a value of 0 to 3 because it's a 2-bit data. Okay, and packet.randomize calls the built-in randomize method on the class object PKT to assign new values to the rand and randc variable. So this is what you have to understand with this program, which is being shown to you all. Okay. So next we'll go to the next slide and understand the next concept of randomize. Okay, so we also have what is called as pre or post randomized methods. As I said, randomize is a function, and we also have pre and post randomized functions which can be automatically called during randomization. So pre is called before randomization and post is called after randomization. And you can override these functions for customization. Okay, you can, while randomize cannot be overridden, while pre and post randomization can be overridden. For example, how can I use them in my program? I'm just showing the same class declaration here. The class name is now transaction, and the variables which are declared as rand, here I don't have rand c here, both are rand. Variable which I have declared as rand are data and ch. So data is 8-bit wide and ch is 4-bit wide. Okay, so before randomization, say I want to check what is the value they carry, what are the values they carry, data and ch. Then what I have to do, I have to just call pre-randomize and display data and ch. So whatever is the default value, whatever they carry, what values they carry before randomize, that will be displayed. Okay, and then I will call the randomize function. And then I want to see after post randomize at the end, what are their values? Then I can just invoke post randomize method, which will also have inside its function the print statement, the $display statement, which displays the values of data and ch. Okay, so see here, what is the process? I have called a module is declared, module test is the first statement here. And I'm creating an object of a T of type transaction, so which belongs to the class transaction. Then inside the initial begin, inside this process, I will instantiate this object within constructor and I use new for that. New is the syntax for that. So T is equal to new. So that initializes all the variables of the transaction of the object T. right? And dollar display, I'm just displaying starting randomization, which prints on the screen. Then I'm calling t.randomize. So I'm invoking the function, invoking the object to initialize the variables which are declared as rand or randc to initialize values with the function randomize. Okay, so that randomizes, that gives one set of random values to data and ch, and I'm displaying that. Okay, so this is what we do, and it's since I have pre-randomize and post-randomize, automatically they get invoked before and after randomize. And what do you get here as the display? So before randomization, data is 0, ch is 0. And after randomization, some random value has been given to data and ch, which is getting printed with the help of post-randomization, right? So that's 154 and 9. And then I've also declared, I've also called dollar display function here after randomize, which displays some message, and that gets printed here, right? So this is what happens when I include. So what is the take of this program? I've included pre-randomize and I've included post-randomize function, which are customized here. Okay, and then when will they get invoked? One gets invoked before randomize is called, and one more gets invoked after randomize is called. Okay, and at the end, whatever statement we have inside randomize, that gets displayed. So that's randomization succeeded, right? So these are the things which, this is this sequence which happens when you call all together, the program has everything together. This is the sequence in which it gets executed, okay? So we can also apply constraints to our randomization. Okay, so constraints, the syntax for constraining your randomization is here example. It's constraint, name of the constraint, and an expression. Okay, for example, I'm saying undersize is the name of a constraint here. So prefixed with constraint, and then what is the variable which I'm putting constraint on? That you have to mention in the expression place. Okay, so I want to constrain packet length, which is a 16-bit data. Actually, in our previous program we have seen. So I want to constrain it to have a value anywhere between 0 to 64. So I'm saying less than or equal to 64. That's the constraint I'm giving. So always undersize will generate a random value, which will always be between this range, which is 0 to 64. Okay, so in that way, you can constrain your randomization on any variable. Okay, so here, for example, in order to make it clear, I've taken an example. So class name of the class is packet. And inside the class, I have one rand variable, which is named as packet length. So that's the variable, which is a 16-bit data. Now, when I have 16-bit data, the packet length can have a value. If it's not constrained, it can have a value anywhere between 0 to 65536, right? 2 raised to 16. It can have any value between that. But now, since I'm constraining it, you can see that it will have a value anywhere between 0 to 64. I made it shorter. Okay, so then I have a display function inside class. Now in the module, I declare an object, a packet pkt of type class packet. So an object of that class is created. Then I initialize all the variables using new function. And then repeat of 5 is used here inside the initial process, which will 5 times randomize your object, pkt. So whatever variable, since packet length is the variable which is declared as rand, 5 different random values will be generated for this. And if successful, I'm displaying it. If randomization is not successful, it goes to the else part and it displays randomization field. Okay, so this is the way you can see one sample result here. Randomization successful. Packet length is 38 for the first time, 38, and then 4 different values will also be displayed because we have given repeat of 5 here. Okay, so this is the way you can put a constraint on your randomization, random variable, which can either be rand or randc for that matter. So now we also have what are called as rand underscore mode and constraint underscore mode. These two are two different functions which you can use in your code. when your variables are rand or ramsey. Okay, so let's see how we can use them with an example. So rand underscore mode is used to enable or disable the variables which are declared as rand or ramsey. Okay, and constraint underscore mode is used to toggle the constraints. Maybe for a certain time you don't want them to have that rand feature, rand characteristic. You can just off it, so that they will never behave like rand. You want to again on them, then you can just toggle the constraints using constraint underscore mode. Okay, and we also have what is called as inline constraints. So that is the keyword with which is used for inline. Let's see with an example and understand these uh, features of randomization. So for example here, I've taken again class transaction. The two variables are rand, which is packet length, which is rand type 16-bit, and I'm constraining packet length. The packet length is now, the name of the constraint is undersize, and undersize is constraining packet length to have a value which is always less than or equal to 64, a decimal value. Okay. Then I'm initializing a constructor. So then inside the process of initial begin, I've taken a local variable int success. Let's see what is that doing. Then if of trans underscore h dot packet length dot rand mode. Now I'm checking whether packet length is randomized. Is it randomized? Yes, it's randomized because it's declared with rand. So if of 1, this returns 1 because packet length is rand. So if of 1 passes, and then it goes to the for loop, which loops for 15 times, and it randomizes 15 different values for packet length. Okay, so that is what happens here. And then followed with I'm doing constraint underscore mode implementation now. I'm turning off the constraint on packet length. When I'm turning off the constraint on packet length, now packet length will have a freedom to have a value anywhere between 0 to 65536, because now it can take anything, any combination of 16-bit, because I've turned it off. The mode is turned off. Okay. Then I'll again randomize now with the inline. What am I doing now? Let it not be less than 64. I've turned it off, and now I'm giving another property to my packet length. Now I'm saying let it be greater than 64. So I'm using an inline constraint here with the keyword with. Now, whenever I call randomize, then the packet length will have a value between greater than 64 to 65536. Okay, that's what I'm doing. I'm just toggling the value of packet length to be less than 64, offing it, and then make it use an inline randomization feature and make it get a value greater than 64. Okay, then I'm coming here and again turning the undersize constraint on. When I turn the undersize constraint on, again, packet length will have a value less than 64. Okay. So now I'll randomize it. So this is the way I can just play around and make the randomized value toggle between any values. So that's about the way in which you can use inline random, then the rand mode to understand whether any variable is randomized or not, and constraint mode to on and off the randomization constraint feature on a variable. Okay, so you can just run this code and see how they actually work. Okay, so that's about how controlling constraints happen in System Verilog. So constraints can be inherited also in System Verilog. You can inherit the constraint. That is to say, if parent has a constraint and you call a child, then child will also inherit those constraints. Okay, so let's see how it works. Taking an example. So I have class transaction, and I have a variable inside this class, which is packet length, which is 16-bit. And I'm constraining packet length with the constraint oversize. Now, what this constraint oversize does is a packet length randomization value of packet length will always be greater than 0. That's the thing we have considered. Sorry, FF00. Anything greater than FF00 will be the randomized value of packet length. Okay. Then what I do, I inherit this transaction class into the child class, which is trans underscore ext. Okay. So, and then here I'm calling a constraint undersize But this constraint undersize is also on the packet length itself. Okay, so this will, the condition for packet length inside the child classes, packet length should be less than or equal to FF50. See what happens now? Now this child has inherited parent, and packet length value in parent, the constraint is it should be greater than FF00, and inside the child it is less than or equal to FF50. So what actually happens is when you use packet length inside the child class, the range of random value which packet length will have is anywhere between FF00 and FF50. It'll be between that. Okay, because the property of parent is also inherited by the child. Okay, so in the process initial begin, I'll use assert, and then I'll say text underscore h, which is a child object. And I'm calling randomize on the child object. And so the packet length will now belong to the child object. So that will have in a random value anywhere between FF00 to FF50. Okay, so that is how it works. So the base class transaction defines a constraint over size, which enforces packet length to this value. The derived class trans underscore x, which is the nothing but the child class, adds an additional constraint under size to the same variable packet length. And now it is less than or equal to FF50. So there is no conflict. So when there is a conflict, we have to see how it works. But here there is no conflict. So when randomization occurs, packet length must satisfy both constraints. That is, be in the range FF00 to FF50, because there is no conflict and it's so clear, and so it follows this condition that it should be between this to this range. Okay, so let's see now, if I have a conflict, what happens? So we call it as, whenever there's a conflict, in order to avoid that, we actually use what is called a soft constraint. So relaxed if conflict with stronger constraints avoids randomization failure. For example, see, if there was a conflict in our previous program, it would have led to an error, randomization error. So in order to avoid that, just see here, I have a class here, which says rand bit. Then we have uh, address. Address is a data, and I have said constraint address underscore range. That's the constraint name, and I'm putting a constraint on this variable ADDR that it should be greater than 15. Okay, it should be greater than 15. So it's a, and I have prefixed it with soft actually. Okay, so what happens here now? I have prefixed it with soft. Now come to the module. Now I'm randomizing this object t underscore h, which belongs to the class trans. I'm randomizing this, but I've used an inline constraint which says you randomize value to this object, but now with address less than 15. It wants all the address data, address variable to have random values less than 15. But in my class, I've constrained it to greater than 15. So isn't it a conflict? So it's a conflict. So what happens? It will see which is soft. Now, this is soft. Okay, the class, uh, the constraint which is defined inside the class is soft. So this will be ignored, and the inline will now consider, the randomize will now consider whatever is put in the inline. Okay, that is less than 15. And now it will generate all the values to the to the variable ADDR, which is less than 15, not greater than 15, because greater than 15 is soft. So it will be ignored. You understanding? So the soft keyword means the constraint can be overridden by a stronger constraint. So now this is stronger because it's not soft, right? In this example, with address less than 15 overrides the soft constraint. Since ADDR is 4 bits, the range 0 to 15, this ensures the randomization still works and doesn't fail due to conflicting constraint, right? So because we have done it soft, okay? In this way, you can avoid conflicts. Now, say for example, constraints are there in a scenario wherein, see the scenario wherein packet length is now given a constraint with the name oversize, and I'm saying that the packet length should always be greater than or equal to greater than or equal to hexa FF00. Okay, so that's the thing. And child inside the child class, so child class inherits all the properties, right? But here I have constraint with the same name. See, both are having the same name now. Earlier it was oversized and undersized, but now this is the same name. And now the packet length, I'm telling it to be less than FF50. Okay, this is greater than FF00, this is less than FF50, and both are having the same name. Now, when I do randomization, I'm doing a randomization on object child, derived class, text underscore h belongs to the derived class. So what happens here? So override happens. It considers the child class constraint because both are of the same name. So it gives preference to the uh, uh, condition which is defined in the child class versus the parent class. Okay, so the transaction class defines a constraint, packet length is this. The derived class defines a constraint with the same name, so packet length less than or equal to FF50. Now, since both constraints use the same name, oversize, the one in the derived class takes precedence, and hence the result is that packet length is constrained to less than or equal to FF50 only. So anything between 0 to FF50 will be the random values which will be generated to the variable packet length. Okay, so that is how you can do constraint overriding. That is how it works. We also have what is called as set membership in constraints. So what do you mean by that? Let's see using an example. So the keyword used here is inside, which you have to remember. So let's see in action the set membership. So we have again a class transaction. The random variable is ADDR, which is having rand as its declaration for a 4-bit data, and I have a constraint on ADC. So which is ADC is the name of the constraint, and it's constraining on the variable ADDR. So what is the constraint it's giving on ADDR? It has to be inside. It has to be either 3 or 7 inside this, either 3 or 7, or any value between 10 to 15, 10 through 15. So this is the condition. Okay, so inside is the keyword. Whenever you're using set membership. So what happens here? So when I have an object now for this class, which is trans underscore h, I use equal to new to initialize all the data. Then we have we initialize the randomize function trans underscore h dot randomize. Then I'd say I'll display the randomized function. So how does it work? The constraint ADC uses the inside keyword to restrict ADDR to specific values 3 and 7 or a range of values 10 through 15. So on randomization, ADDR will be assigned one of those legal values. Anything between these will be assigned to ADDR. Okay, so this is how it works. You can also take set membership for an array. So I'm taking an array, 4-bit array. The name of the array is ADDR underscore previous. And what are the values in that array? 1, 2, 3, 4, 5, 6, 10, 11. Now, when I constrain ADC, when I use constraint ADC, ADC is again the name of the constraint, and it's working on ADDR variable. Inside is the keyword which you have to use in set membership. And this is the flap bracket syntax which you have to use. And inside what? I'm using this array. So what will this expand to? It will expand to 1, 2, 3, 5, 6, 10, 11. So ADDR should have a value anywhere among these 1, 2, 3, 5, 6, 10, 11. That is what I'm restricting. I'm constraining the ADDR to have. Okay. So when randomized function is called on this class object, the variable ADDR, since it's randomized, since it's declared with rand, will whenever randomize is called, it will get a random value which will be between these values, among these values. Okay, so that is how it works. And so remember the keyword inside. So that is the keyword for set membership. You can also use distribution constraints. So when you say distribution constraints, the syntax is colon equal for equal weight per item, or colon slash which distributes total weight over a range. For example, I have here VLang tag, which is a data. What am I declaring that to have? Dist is a syntax for the distribution constraint. I'm saying VLAN tang can have 7 colon equal to 5. So that is what I mean. 5 is the value. Whenever 5 is the weight for a value which is 7, or from between 11 to 20, if the data is generated, then it should have a weight of 3. Or if it's anything between 26 to 30, it should be having a weight of /5. Let's see what is this actually with an example. So I have here class transaction, and data is a variable, which is rand data, which is an 8-bit. Now, what am I doing? I'm applying distribution constraint on it. So how do I do that? Constraint, name of the constraint, which is dist underscore c, flar bracket, and what is that which I want to put a constraint on, distribution constraint on this variable. So data, and then syntax is dist, flar bracket, and then I'm saying whenever data has a value between 101 to 105, give a weight of 200. That's what I'm saying. Each value from 101 to 105 gets weight 200. And whenever I have a value between 106 to 110, give a weight which is /100. I'm saying /100. So whole range gets 100 weight distributed equally. That is, I have 106 to 110. So each gets so how many values do I have here in this range? 5 values. So each 100 by 5, it divides these 5 values with this distribution value 100. So 100 by 5, that means 20. So each value between 106 to 110 gets a weight of 20 because 5 values, right? So 100 by 5, which is 20. So 20 will be equally distributed for the range 106 to 110. Okay. So whenever you randomize, and if the value is somewhere between this or this, this is applied on these values. Okay. So assigns weight to each item in the range. Example 101 to 105 each gets weight 200. Assigns total weight to the entire range divided evenly. Example 106 to 110, each gets 100 by 5, which is 20. So the dist keyword defines distribution-based constraint. Okay, so please execute this on EDA Playground or Vivado and just see how the values get distributed. So here one more example. See in this VLAN tag dist 7 colon equal to 5, I'm saying. So the value 7 has a weight of 5, and 11 to 20 has a weight of 3. So each value from 11 to 20 will get a weight of 3, and 26 to 30, which is, I've given it as colon /5. So the entire range 26 to 30 shares a total weight of 5, because 26 to 30 is 5, right? So each gets, it's 5. So 5 by 5. So each gets a weight of 1 because they share a total weight of 5. So when they share a total weight of 5, they get distributed among the 5. So 5 by 5, which is weight of 1. So that is how this works. Conditional constraints. So in conditional constraints, we have conditions with if. It's very much like if else. So one is the implication method, which says implies, and the other is the if else method. Let's see how we can use conditional constraint using an example. So I'm using implication operator here. So implication operator is the symbol. Okay, the minus and the greater than symbol. It's an arrow kind of symbol. So I'm having class transaction, and the value which is randomized is VLAN tag. That's the randomized variable. So I am putting a constraint. The name of the constraint is tag. Okay. And what am I constraining? Which data I'm constraining? I'm constraining VLAN tag. VLAN tag. So what am I saying? If mode is 1 tick B1, if this is the mode, then what should VLAN tag be constrained to? Less than 96. If mode is 0, I'm constraining VLAN tag to be less than 1248. So that's the constraint I've put inside for the data VLAN tag. Now when I randomize, and I'm setting the mode of the object trans underscore h as trans underscore h dot mode as 1. I'm setting it to 1. So now what is the constraint for VLAN tag? Less than 96. So when I randomize the object, VLAN tag will always get a value less than 96. Okay. So because I'm doing the mode as 1. Suppose I, again, eventually I make the mode as 0, then VLAN tag will get a changed constraint, which will be less than 1248. Now, instead of this arrow thing, I can also use if else. right? There are two ways in which you can give a conditional constraint. So I'll just say constraint tag. If mode is equivalent to 1 tick B1, VLAN tag is less than 96. Else if mode is equivalent to 1 tick B0, VLAN tag is 1248. So same thing. Same thing, instead of implication operator, I'm using a if-else operator. This is how it works for conditional constraint, okay? So we also have static constraint, if this program is visible to you all. Static constraint for constant restrictions. So example, I give the syntax as static constraint and whatever variable you want the static constraint on. So that's the variable name. And what am I saying? Address should be greater than 8, okay? So here I have random, a bit is a, ADDR is a random, is a variable which is randomized for a 4-bit. And then I'm saying static constraint valid underscore ADTR to have a value greater than 8. So when I do that, see what happens. Then I have module static this is the name of the module anyway. Then inside that I'm creating two objects now, T1 underscore H, T2 underscore H. Two objects are created and I'm initializing them, instantiating them with one or two new instances. T1 underscore H has now all the variables declared with initial values. T2 underscore H is an object declared with initial values. Now I'll say assert of T1 underscore H dot randomize. Now it returns, if this function fails, it returns a failure, right? Otherwise, it will have a constraint on ADTR to have a value greater than 8, okay? Then I'm saying the screen I'll reduce so that you can see what's actually happening here. Here it is, the screen has gone the other side here. So I'm just calling assert T1 dot underscore H dot randomize and T2 underscore H randomize. So they all will be, when I say that, they'll have an a value of anything between whatever constraint I've put on, greater than 8, greater than 8. So that is how they work. 1 minute. Let me reduce the screen and I will show you. On the screen here. How do you call it? You have to just call it as T2 assert of T1 underscore H dot randomize to check whether randomization is success or failure. If it's failure, it returns a failed message. Then I'm calling T2 underscore H dot ADDR underscore range dot constraint mode of 0. See, I've turned on the mode as 0, 0 here. So that is what I've done here. So this has no constraint. It's not turned off. It is there. The randomize will work on T1 underscore H, but here the constraint underscore mode, I've made it 0 here. Okay. So now I'll assert T1 and I'll assert T2 with randomization. So here earlier it was only T1 underscore H dot randomize. I'm just checking, giving randomized values to T1 underscore H. So I just want you all to run this program and just see what are the values you'll get and why static constraint, why this is used and what's the use of this. Okay, with this example, if you work on this example, you'll understand how they actually work. Go to the next slide. We also have what is called as the extern constraint. So when it is extern, we have we call defined outside the class. See here, I don't have. I have a packet class packet. It's been defined here. And I'm not defined constraint inside the class. I want to define it outside the class. Then what do? You use a scope resolution operator. So packet and what is the return type? It's constraint on packet and valid underscore ADDR is the name of the constraint. And what are you constraining on? You're constraining on the variable ADDR to have a value less than 10. So see, you can also use constraint externally. You can use the constraint feature on any of your variable of your class, which can be done using the scope resolution operator. So earlier we used to define all the constraints inside the class. What if you want to what if you decide later that you want one of your variable to have constraint and it's not defined inside the class? Then yes, you can do it outside with the scope resolution operator. Okay. So, and I'm using here with operator here, which says the inline thing which we have used here for ADDR to be less than 5. Okay. So that is what. So inline constraint, we already have taken example earlier. The use of keyword with is for inline constraint. So for example, here I've said constraint, C is the name of the constraint, and what is the condition? I want uh, Z, the third variable, which is random variable, uh, equal to x plus y. Okay, whatever x is generated and whatever y is generated, any random variable, the sum of these two should be the value for z. That is what I put the constraint as. So whenever randomization function is called, the other condition also which I put in the inline is x should be less than y. Okay, so always x is generated and that it's taken care that the value of x which is random, which is generated, will always be less than y. Okay, and the sum of these two will be given to z. That is what this constraint will decide. Okay, so like that, you can put inline constraints and give expressions according to your convenience for randomization. Also, we have scope randomization. So how do you do that? You use STD scope resolution operator randomize. So let's see how that is used in our example here. See, I'm not using any class. Now my variable is not inside the class. So then how do you use randomize? So for example here, module test AB bit success. Now these are not inside the class. These are not variables inside the class, and they are not rand or rand C now, but they're just inside a module. Now, when you want to randomize AB, you have to say, use this scope randomization syntax, STD scope resolution randomize of A comma B. And what is the condition I'm putting? A should be between 10 to 20 and B should be between 50 to 100. That is what I've put as my constraint. And then I'm displaying the value that gets generated, that gets randomized. Okay. So this is for scope randomization, wherein I have to use the syntax because they are not my class variables anymore now, right? Because I don't have these variables defined inside the class, and hence they are not rand and ranc. So this is the way you have to do it when something is not a class variable. So when you can also have called the constraint inside, calling functions inside a constraint, you can do that. For example, here I have class packet. Then I have two variables which are s underscore addr and a underscore addr, which belongs to rand variable, rand type. Then I'm constraining the value of e underscore addr. This value I'm constraining. Okay. What am I constraining it to? I'm constraining it to something which the function defines. So ADDR, it should be equivalent to the written value from the function. So E underscore ADDR should be assigned to a value which this function returns. Okay. And what is it returning? It's returning this variable. The function is returning this variable. So that is what we are doing here. So my function is addr underscore calc. That's my function name, and return type is s underscore addr. So I have some condition here. If of s underscore addr is greater than 8, I'm saying addr underscore calc to be 0, else addr underscore calc to be s underscore addr plus 2. Okay, so that's what I'm saying. So it all depends on the value of s and e underscore addr will now depend on this. So this is written, right? So this is written and that gets assigned to E underscore ADDR. So you can work on this and understand how it really works. So summary of randomization, randomize is something which is a virtual function of class, which is an inbuilt function which you can't override. Pre-randomize and post-randomize are built-in methods again and can be overridden. Rand underscore mode and constraint underscore mode, they are used to enable and disable rand and constraints. Constraints are inherited to child class. Same constraints name in child class will override the parent constraint. Different name, solution space depend on constraints. Constraints are declarative and bidirectional code. Randomize fails when there is a conflict in the constraint. Randomize with inline constraint, we have understood. Okay. So please understand the static randomization, which I had shown as an example. And I want you all to run that code and understand what actually happens there. So that is this program. I want you all to work on this and understand the concept. Okay. So that's about randomization of module 4 part 1. Thank you.